The developed application for Task 6.3.3 aims to monitor various parameters of a real induction motor or its digital twin, make predictions based on this information and provide smart recommendations. Specifically, the monitored data corresponds to the vibrations of the two bearings, the magnetic field associated to the rotor and the temperature of the motor housing. In the graphical user interface there is a dedicated tab for displaying the results of the analysis of each one of these signals. For start processing, the data source must first be selected. In this case, a pre-recorded data sequence simulating a gradual degradation of the second bearing is chosen, and the analysis started. Vibrations and magnetic field data are pre-processed to carry out a spectral analysis to determine at what frequencies are located the 5 higher peaks of the signal and their amplitude. Then, this information is sent to 2 independent neural network models to predict the remaining useful life and status of the component. When the bearing is operating under normal conditions, or the fault is imperceptible, the spectrum doesn't show anything unusual. However, when the effects of the fault start to become noticeable, peaks start to appear at certain frequencies in the spectrum. The outputs predicted by the 2 neural network models are used as inputs to a fuzzy inference system that recommends one of 4 possible actions: repair, immediate maintenance, preventive maintenance, or no action. The global notifications pane shows if an action is recommended for any component. Then, by selecting the tab corresponding to the faulty component, it can be seen how the system is capable to detect the gradual degradation of the component and consequently, modifies its recommendations until a repairing is needed if preventive actions are not properly taken. Faults do not always occur in a gradual manner. In some cases, the fault can occur unexpectedly. As an example, a pre-recorded data sequence simulating a sudden fault on the rotor is chosen, and the analysis started. Now, the global notifications pane indicates that a fault was detected in the rotor bar, and by navigating to the corresponding tab, it can be seen how the recommendation of the fuzzy inference system rapidly changed from no action to repair. Some faults can have multiple consequences. Here, besides of the expected influence on the magnetic field spectrum, the temperature also starts to increase abnormally, surpassing the acceptable threshold. Summarizing, the application suggests recommendations for the operators that can help ensure the reliability of the electromechanical device.